multi-stage water filtration and purification process of Aqua Clean Water Services. Water from the river continuously flow from the mountain until it goes at the side of the houses. However, it is not only the water element present in the river or stream but also those unnecessary debris floating on it which may enter the pipeline. In order to hinder this debris, screening process is the first operation of the business for the water treatment to work. At this stage, the business uses screen to block unnecessary materials. This process essentially involves the removal of large non-biodegradable and floating solids that frequently enter a wastewater works, such as rags, papers, plastics, tins, containers and wood. Efficient removal of these constituents will protect the downstream plant and equipment of Aqua Clean Water Services from any possible damage like pipe blockages. Typically, opening size of the screens used by the business are 3 to 10 millimeters. Moreover, since the business station is too far from the water source, it needs to put up a single motor pump approximately 700 meters from Salacea River. This pump has 3 horsepower, which means that the pressure of the water in the pipeline is only enough to reach about 500 meters to 750 meters away. The water being pulled, which is already past the screening process, will directly store in the tank or reservoir with a capacity of 3,000 liters. This tank serves as a temporary storage area or terminal of the water since it could not reach the station straightforwardly. When the water reaches the first tank, another motor pump is putted with the same capacity to pull the water again until it extends to the reservoir near the business station. This reservoir will be the secondary raw material tank of the business before processing it in the purification system. Before purification, these raw materials will still pass through another pump, booster pump. The pump delivers the water from the reservoir to the pressure tank. This tank allows the water system to work on demand, which has both water and compressed air on it. As water is pumped into the tank, the pressure changes. This pressure change activates a pressure switch that turns the pump on and off. Once the water passes through the pressure tank, it will directly flow to the 3 carbon tanks which use to filter and remove contaminants, using chemical absorption. The next process is called carbon filtration. The first tank is called activated carbon, second tank is multimedia sediment filter and the third tank is ion exchange sediment filter. Carbon tank systems remove a wide range of contaminants including chlorine and chloramines. It also removes most other chemicals, tastes and odors, and is an excellent system for general filtration. Additionally, a brine tank is also connected to ion exchange sediment filter, which serves as a container where the industrial salt will be added in the process. This kind of salt will be an intermediary which assists in cleaning water. At this stage, when the water reaches the tank of ion exchange sediment filter, an industrial salt is added to remove bacteria or micro-impurities. According to supplier of the equipment to use, there is approximately 2 sacks of industrial salt that will going to consume every month of production. Reverse osmosis works by using a high-pressure pump to increase the pressure on the salt side of the row and force the water across the semi-permeable row membrane, leaving almost all of dissolved salts behind in the reject stream. And row membrane rejects the contaminants based on their size and charge. Any contaminant that has a molecular weight greater than 200 is likely rejected by a properly running row system. Furthermore, the more concentrated the feed water, the more pressure is required to overcome the osmotic pressure. As the feed water enters the row membrane under pressure, enough pressure to overcome osmotic pressure, the water passes through the semi-permeable membrane which blocks the salts and other contaminants to pass. The water block in the process will be discharged through the reject stream, also known as the concentrator brine stream, which goes to drain. The orange line in the diagram represents the water supply in some circumstances to be recycled through the row system to save water. It is anticipated based on the statement of the business equipment supplier. 60% of the water being processed will fall in the wastewater treatment, which could still be used for washing clothes and dishes or even for bathing. In order to reuse and reduce the disposal of waste, the business connects separate pipeline to transfer this water to the storage tank or reservoir intended to sell for consumption. The remaining 40% of the water created using Powtoon.